Hey everyone, this is Zach with AIAA Rocket League, and this time around for this tutorial, I'm going to be showing you how to design a 3D nose cone in Solidworks for 3D printing purposes. This is honestly my favorite part of L1 design, just because I love the way that you can design a nose cone in Solidworks from a simple equation, and then watching it come to life on the 3D printer. It's hard to describe. I don't know, I get excited about it, maybe you will. Obviously the first thing we want to do is make sure we cross-reference our open rocket, so I will have my nose cone dimensions here. These values are very important, so just keep all of this in mind, including the shoulder, because we're going to design the whole thing. What we want to start by doing is obviously going to SolidWorks. This is just the welcome screen. I already have a nose cone here, but we'll ignore that. I will just create a new part. So it might take a second to load. And then the first thing I want to do before I design anything is make sure this is set to IPS, just to be consistent with OpenRocket. Yours may default to IPS, mine does not, but we'll do that for now. So the first thing I'm going to do before I design anything, before I even look at the numbers or draw anything, sketch, whatever, I'm going to go here, and I will actually give you this link. When we're going to learn basic nose cone design here, it's called the tangent ogive, I don't know how to say it. Basically, it's good for hobby rocketry, like it says here, low speed stuff, and it's created by getting a circle with radius rho, and then if you did this equation right, you should end up with a nose cone shape just like this that you can do a revolve around with the exact radius and length that you need just from this equation, and that is expressed right here. So this is all you need to know. R is going to be your body tube outer diameter, very important, your base diameter for the nose cone. So just to keep in mind, that's this number. One thing that people tend to screw up when they do 3-inch tubes is they have the base diameter as 3. That is not true, because it's the outer diameter is actually 3.1. The inner diameter is 3, but the outer diameter is 3.1. So your R is going to be 1.55 because that's half of it. L is the length of the nose cone, so that would be this value, 7. And then 2R is just 3.1. So we can start our nose cone in SolidWorks. So I will go back to SolidWorks. I actually have the calculator open here and ready. So what I'll do is I will just design this on the front plane, because why not? So we'll right click that, we'll click normal 2. If you hear the police in the background, I apologize. So we'll start with the circle. So just a standard center point circle, get that at the origin here, and just bring it out. So in order to determine what the radius of the circle is, we obviously have to do that equation. So it's r squared plus l squared over 2r. R is not 3.1, it's 1.55. So 1.55 squared plus 7 squared equals 51.4025. That's that top value, divided by 2r, which is just diameter, so divided by 3.1. 3.1. And that is now rho. But that is our radius, and something that SolidWorks does that is a lovely thing is when you click on Smart Dimension here and you go to dimension this circle, you will get the diameter, not the radius. That is very important to make sure your value is correct. So we'll just double this times 2. So the diameter of this circle will be, what was that, 33.163, and it doesn't have to be too exact, because essentially once you do this, it'll give you the right value. So the next thing that we're going to do is I will go up here, grab a line from the center up here and draw it downwards, and then I'll get out of that, and I will dimension this line to be the radius of the nose cone, which is 1.55. So now and this is the coolest part. If I did that equation right, I should be able to draw a line from this center point to the edge here, and it will be exactly 7 inches. Look at that. So, if I try to dimension this line, it'll throw a fit. Yeah, so I'll just leave it like that. It basically threw a fit, but that's a 7-inch line, so you don't have to dimension that line because we know it's 7 inches. So now what do? I have this big old circle here that I don't need. Well, there's this great thing called trim entities. I just click that up here and I drag right through there, and bam, I have a nose cone. So now I can exit this sketch. Actually, I do want to be in it. So now that we have that nose cone shape, we don't need open rocket anymore, really, because, well, we do, because we have to do the shoulder. I lied, sorry. Next thing, features. We are going to do a revolve boss base, not an extruded, revolve. And then I just click on that line right there, and it will revolve it automatically 360 degrees and give me my nose cone shape. So that's a nose cone without a shoulder. So here's what we'll do to give ourselves a shoulder. I will right click on this face and normal to this face, and I will start a new sketch on this plane. Get another circle, and if you highlight over the edge here, it should give you the center. And I will now, it doesn't matter the size right now. And this is our shoulder. So this one we want to dimension to a 3-inch diameter, not 3.1, because this has to fit in the tube, so 3 inches. And now the super simple part about this is I will go here, click features, extruded boss base, and extrude this out 3 inches because that's what our value was, and bam, shoulder. Now, before you can 3D print this, we have to fix it, because if you left it at this, it would print everything filled in, and you would waste so much filament that you would be crying and screaming because of how much money you wasted, and the fact that it probably wouldn't be able to print the whole thing off of one spool. So the next thing we're going to do is we're going to click on this lovely thing called shell right up here. It might be a bigger button, but just click shell. And then what I'm going to do is I'm going to click this face, and we're going to do it at 0.2 inches because that was what our thickness was. Click enter, and bam, it shelled out the entire nose cone for us. So now we have the exact nose cone from Open Rocket because of that 0.2 inch, and it's not filled with the shoulder and everything, just from this equation. It's like the coolest thing ever. You just get a circle and you suddenly have a nose cone. But yeah, so now that's shelled out with a 0.2 inch thickness, what we're going to want to do is we're going to go up here, click File, Save As, and this is not going to be a part or a DXF, it's going to be an STL. This is a 3D printable file. I'll just call it nosecone L1 STL, and it'll give you this weird stuff. And basically, yeah, you just save that file. All you would have to do then is bring a STL file on a USB to the TI lab. They will be able to do it for you. Those printers are calibrated specifically for nose cones, and they'll probably do a 20% infill, but that should be giving you the perfect nose cone. So yeah, that's how you design a nose cone in Solidworks.